Hello, everybody, and welcome to this webinar on the research conducted by Frontex and the EU Innovation Hub for Internal Security on high-altitude pseudo-satellites. After a short introduction, we will cover the main study objectives. Then, passing on to the main bulk of this webinar being the study result, and final conclusion that can be taken out of this study. This study aimed at assessing the potential of high-altitude pseudo-satellites, or HAPS, as a technology for the activities of both Frontex and all the members of the EU Innovation Hub. But what is HAPS? HAPS, generally known as high-altitude pseudo-satellites within Europe or high-altitude platform stations within the United States, are advanced unmanned flying systems that operate in the stratosphere or higher airspace, meaning around 18 to 22 kilometers above sea level or 59,000 to 70,000 feet above sea level. As you can see in the graph, HAPS, or high-altitude pseudo-satellites, can be considered as a mix between satellites and drones, but we will be providing more information on that later on. Regarding now the study objectives, this study intended to provide an analysis of the HAPS market and an assessment of the potential or the limits of HAPS as a capability enabler. The outcomes of the study would serve as a baseline to review and evaluate whether and to what extent EU Justice and Home Affairs community stakeholders can utilize this technology and, of course, maximize the solution they provide. In terms of scope, the assignment will be covering at the global scale to address the requirement of the market research and benchmark analysis, but still trying to keep an EU focus. In essence, the study will cover three main areas: an analysis of the HAPS state-of-the-art, or SOTA, and market, a technological assessment of HAPS applications, and a preliminary assessment of the impact of HAPS on fundamental rights assessment. It is important to note that this assessment focuses solely on the implication for the EU Innovation Hub mandated operations and therefore explicitly excludes any other use, for example, within a military or private context. Moreover, the assessment is performed against EU fundamental rights standards. Last but not least, this is a webinar summarizing different reports that have been published on the Frontex website, and we can only advise you to go have a look at those amazing reports, which provide much more details on the matter. If we now look at the main study results, we will be covering, as we said, the three reports that were drafted for this study. The first report is a market report. The first part of the study was threefold. First, a review of the state-of-the-art, or SOTA, including an overview of the different subcategories making up HAPS, the evolution of the technology, the main benefits and downsides, and the legal framework surrounding the project. The second part of that report is a simplified market research on HAPS, including a general overview of the HAPS market, an assessment of the main available applications, and an analysis of the growth opportunities. And last but not least, a benchmarking and comparative analysis of HAPS and its premier competitive technologies, including a SWOT analysis for each of them. If we dive into the review of the state-of-the-art, HAPS is often compared to unmanned aircraft systems. The main difference between UAS and HAPS is the flight duration. It can go from weeks to months for HAPS, and usually maximum 1 to 1.5 days for large UAS. Another important element is that HAPS, as previously mentioned, operates at a stratospheric level, so meaning between 18 and 22 kilometers above sea level. HAPS is not a new concept. It exists since the 80s, and its development was mainly driven by advances in power-related technologies, exterior frames, flight automation, and aerodynamics, as we will see later in this webinar. We can distinguish mainly two types of HAPS application, what could be called as lighter than air and heavier than air. And within the lighter than air category or type, two subtypes can be identified, balloons and airships. If you look at the development difference per type of HAPS application, LTA airships or lighter than air airships are still mostly in the testing phase, while LTA balloons are utilized for commercial purposes in the communication sectors and also explored for remote sensing and surveillance. HTA, or heavier than air, development drivers are remote sensing and ISR, or intelligence, surveillance, and reconnaissance applications, with a specific interest in the security sectors and some platforms already out on the market. If we now look at the main benefits and downsides of the different HAPS application, on the benefit side, we can clearly state from the study that the ability to retain a position for extended period of time as they operate in the stratosphere is a main benefit. We can also cite the lower latency, better maneuverability, lower capex, coverage of remote area, adaptable payload, and of course the fact that HAPS application can be brought back to ground for maintenance, linking it with a strong sustainability factor. On the downside, HAPS are highly vulnerable to natural factors, as we will see later on also. They have a high OPEX, they have a limited structural endurance. There is currently an ambiguous regulatory environment due to the lack of legal boundary between airspace and outer space mainly, and smaller coverage area per device compared, for example, to satellites. If we now look at the simplified market research, we can say that HAPS is a nascent but with significant growth expected technology. In the coming year, we can foresee a significant growth of that technology. Each platform type presents different forecasted developments. If we look at LTA balloons, there was a huge setback due to the shutdown of one of the main projects, namely the Google Loon project in 2021, but the growth has resumed since. Its development is mainly driven by scientific, weather-related communication and ISR use cases. LTA airships are the least mature category. The current revenue is around 2.4 million euro, and the development is driven by the North American and EU markets. Last but not least, HTA, or higher than air, HAPS application, are currently the biggest market, with a current revenue of 173 million euro, and its development is driven by 5G or telecommunication, ISR, and other communication use cases. Some challenges around the development, no matter the type of platform, are the high energy requirements to allow long period of flight, the exterior structure limitation in order to protect from natural factors, the thermal management, the altitude of operation, as said previously, the solar panel efficiency in order to gain and store sufficient energy for extended period of flight, and other non-technological challenges such as the quality and interoperability of the service. If we now look at a short benchmark on competing technology, we can say that the overview of the competing technology, on one side, we have the UAS or drones. For UAS, the main advantages is that their deployment is quick and easy. Moreover, it's also cheaper to procure and operate than HAPS application. On the other side, the downsides of UAS or drones are the limitation in flight duration and range, also the interference with current air traffic, and it is subject to tropospheric weather conditions. The second competing technology are satellites. Satellites have a big advantage. It's a proven and tested technology that provides a global coverage. Moreover, satellites can carry almost any type of payload. On the other hand, satellites require a large constellation, and there is a really high cost for launch and operations. Last but not least, the third competing category are traditional aircrafts. In terms of downside, we can quote the difficulty to stabilize over a specific location, the high purchase, maintenance, and operation cost, while on the positive aspect, it is similar or higher to UAS, in terms of mission range and duration, and it has a heavy payload capacity. Overall, one of the main conclusions from this study is that HAPS is best used in conjunction with other technologies. What can be concluded from this first study? First, we can say that HAPS has a real potential to be a capability enabler according to the market research, especially in conjunction with other systems. Due to benefits such as the adaptable payload due to reusability, operational and focus on a specific area, the low capex, it occupies a sweet spot between UAS or drones and satellites. Of course, it's still for some application at an early stage of development in terms of power supply or regulatory framework, but a significant growth can be expected in the coming years. The second part of the study was the technological assessment. In terms of objectives, we can quote three different objectives. The first one was the identification of use cases for HAPS by Frontex and the larger justice and home affairs community. The second objective was the mapping of the various available HAPS applications and payloads. And finally, an assessment of the technological readiness level of HAPS application through the lens of the use cases was realized. The common challenges amongst HAPS platforms, LTA airships, LTA balloons, and HTA, are the power system, especially during night operations. There is obviously no sun to power the solar panels. Second is the material and structure reliability, and therefore the materials evolution is key to ensure reliability and success of future operations. Third, environmental factors. As HAPS is evolving in the stratosphere, there is a low air density and varying environmental conditions, representing a major challenge. As the platform can stay up for months, seasonal changes have a great impact, including wind patterns and solar irradiation. Last but not least, weather forecasting is also a major challenge because HAPS require precise and advanced weather forecast models to ensure long-term operation viability. Other commonalities include the fact that HAPS, as said previously, is currently in a development phase, and a lot of developers or manufacturers are confident to have a reliable services as from 2025. It must be noted, however, that some manufacturers are already on the market. In terms of differences, the main differences that can be quoted are the lift generation methods, the technological readiness level, and the maneuverability. For the lift generation method, HTA, or heavier than air platforms have fixed wings with a large wingspan. They do a circular motion, ascending during the day and gliding down at night. It is crucial to avoid damages from jet streams. LTA, on the other side, rely on buoyancy. They have a significant aerodynamic drag and a strong propulsion systems to keep the platform stationary. Some LTA can also have a drift mode, shifting against the wind during the night and drifting with the wind at night. HTA platforms have a slightly higher technological readiness level, or TRL. In terms of payload, HTA have a smaller payload capacity, while LTA have a higher one, and they can potentially carry several instruments simultaneously. Last but not least, HTA are more maneuverable and they have an ability to operate in stronger winds. If we deep dive a little bit on the different payloads, there is currently a necessity for high resolution, reliability, low power consumption, versatile operation modes. But if we look one by one, optical payload, currently we can see a TRL or technological readiness level of 8 to 9, which is very high. HAPS, for example, is very suitable for Earth observation. Different options are already available, like near-infrared, infrared, RGB, monochrome, etc. And image resolution ranges from 8 cm to 30 cm. It must be noted that live video feed is already possible. In terms of telecommunication payloads, the primary application include radio frequency communication, suitable for simple signal reflection with a limited speed and encryption capabilities, but also laser communication with secured links, but with the downside of the need of a cloudless sky and high precision pointing. Also, ground infrastructure development are needed. If we move on to sensors and radars for HAPS, it is essential for gathering environmental information alongside optical system. Technology provides high-resolution imaging regardless of weather conditions. Safe monitoring of hazardous areas from high altitude can also be done. A moving target indicator, or MTI radar, can track vehicles and ships. Distributed imaging radar technology, or DIRT, offers near real-time surveillance with high-resolution images. All those conclusions on sensors and radars were shared by payload manufacturers. Then moving on to light detection and ranging technology, or LIDAR. This technology uses laser pulses for distance measurement. It's extremely valuable for topographic mapping, forestry, archaeology, and security operation. It is sensitive to object movement and provides high tracking accuracy. Electro-optical infrared sensors can detect electromagnetic radiation in visible and infrared spectrum, and it is suitable for surveillance, target tracking, and disaster monitoring in low light conditions. If we try to summarize a bit the different elements of the HAPS payload, is that it must meet stringent requirements for optical, telecommunication, and sensing application, and it enables capabilities from Earth observation to secure telecommunication, but also target tracking. If we now look at the different challenges in the HAPS utilization, the challenges can be categorized into technological, infrastructural, and regulatory obstacles. For the technological challenges, there is a focus on hardware systems for airworthiness. There is a high demand for material performance and certification in stratospheric environment, which we have seen represent a huge challenge, and notable improvements are possible through the resolution of some of the existing technological challenges. In other words, a lot can be done and can improve the utilization of HAPS applications. In terms of infrastructural challenges, there is variation here between HTA and LTA platforms. HTA platforms often require long runways, specialized landing gear, robust communication, and navigation systems, while LTA platforms need large obstacle-free landing areas. But we have also universal challenges both for LTA and HTA, which include launch sites, weather conditions, and large infrastructure. The last category are the regulatory challenges. The three main dimensions, aircraft operation, aircraft certification, and radio spectrum, compose this category. During the different interviews conducted in this study, we realized that HAPS operation face a regulatory vacuum because of the new environment. There are divided opinions on the impact of lacking EU regulation on HAPS. Countries may have flexible approaches based on safety risk in scarcely populated areas. Different stakeholders anticipated regulatory challenges to outweigh technological readiness achievements. In order to assess the potential use of HAPS as a technology, 3 high-level use cases and 5 specific use cases have been analyzed. Regarding the high-level use cases, we have Earth observation, telecommunication, and navigation. Earth observation, we can say that HAPS offers a significant value for Earth observation in the European security ecosystem, as they allow for continuous and high-quality surveillance, surpassing satellites in image resolution and endurance, and outlasting UASs. Regarding telecommunication, HAPS are poised to play a significant role in this sector, complementing existing satellite and terrestrial networks, as they can provide direct-to-device (D2D) connectivity, offering faster, lower latency connections with better indoor coverage and higher capacity compared to satellite-based solutions. And HAPS offers also advantages for navigation use case due to the proximity to the ground and the potential to deliver more precise and reliable navigation signals than satellites, especially in areas with obstacles like city centers, mountain valleys, and forests. Beyond the assessment of the potential and technological readiness of HAPS for the 3 high-level use cases, 5 additional specific use cases were established to assess the potential of HAPS through the lens of relevant operational activities. The 5 specific use cases included in the study entailed search and rescue missions, cross-border remote sensing observation monitoring of point of interest, remote vehicle US IoT operation, covert operation, and the provision of ad hoc backup telecommunication network and GNSS. While some specific use cases would benefit from either the implementation of HTA or LTA solutions, leveraging LTA for covert operation, for example, is ruled out given its maneuverability, whereas the increased payload capacity offers more possibilities for the telecommunication and GNSS use cases. HAPS in general proved to have a significant potential for each of the selected use cases. If we now look at the conclusion of this report, let us remind ourselves the objective of the technological assessment report. The technological assessment report aimed at assessing if HAPS as a technology could be a capability enabler for Frontex and the EU innovation hubs. We have seen that the promising potential of high-altitude pseudo-satellites in Europe for internal security has been demonstrated. The evolution from conceptual ideas to tangible technology with revolutionizing capabilities is progressing fast. On the comparison of LTA and HTA solutions, we can say that HTA platforms have a faster development. They represent ease in handling. They have a better maneuverability, while LTA platforms have a higher payload capability and capacity, extended station keeping capabilities also. The market entry of both type of platform in 2024 signals a promising future for the HAPS applications. The main tangible benefits of HAPS can be seen in the three high-level use cases that were analyzed: the Earth observation, telecommunication, and navigation. And we can quote, for example, the extended live video feeds, high-speed laser communication links, and enhanced network redundancy. 5 specific use cases have also been identified and analyzed through the lens of the technological aspect, and each demonstrated HAPS potential in those applications. Some challenges currently faced by HAPS must be underlined, such as the technological complexity, the environmental harshness, and of course the regulatory gaps. Industry and regulatory bodies have declared being actively addressing those challenges. If we look at the future, we can expect a rapid growth of HAPS application between 2025 and 2030. Of course, stratospheric environment represents engineering challenges, but the market potential drives significant investments. EU's internal security ecosystem will probably benefit significantly from this emerging technology. HAPS could play a pivotal role in enhancing European internal security in the coming years or coming decades. The third and last report of this study was the preliminary assessment of the impact on fundamental rights. Once again, it must be noted that many information have been detailed in the report, and we kindly invite you to consult these on the Frontex website. We must note, especially for this report, that it entails a preliminary assessment of the potential impact of fundamental rights of deploying HAPS as a technology within the operation of Frontex and the other EU Innovation Hub member. As a result, it is important to note that this assessment focuses solely on the implication for their mandated operation, and therefore explicitly exclude any other use cases, for example, within a military or private context. Secondly, the report predominantly limits itself to the preliminary assessment of the use cases against EU fundamental rights standards. For the assessment of these use cases against national legislation of member states or third country if relevant, ECHR, the European Court of Human Rights, and the Court of Justice of the European Union, and a more focused, in-depth review must be carried out. The objective of this report is to provide a preliminary high-level analysis that maps the potential impact of utilizing HAPS. It serves as an initial exploration of the technology's implication and does not aim to replace a comprehensive legal assessment. If we now move to the 3 objectives of this report, we can say that the first objective was to assess which fundamental rights could be impacted. The second objective was to assess if some absolute rights could be impacted too. And last but not least, to assess the precise impact, and in case some impacts have been identified, to suggest some mitigation or safeguards. If we look at the potentially affected rights, and we will only detail some of them in this webinar, we can see that the right to life could be positively and negatively impacted. The deployment of HAPS may indirectly affect the right to life by influencing the choices of asylum seekers and migrants who may opt for riskier routes due to the fear of interception. However, HAPS can also have a positive impact by aiding in disaster management and humanitarian effort, enabling better search and rescue missions, as we have seen earlier. Overall, with the right safeguards, HAPS can enhance the right to life. The second right that we can deep dive is the prohibition of torture, including the non-refoulement principle. While the use of HAPS technology itself doesn't directly limit the prohibition of torture, the potential misuse of data obtained from HAPS that poses a risk. Safeguards are crucial to prevent abuses of collected data and ensure compliance with this fundamental right. The right to privacy was also deeply analyzed. Concerns about HAPS deployment impacting the right to privacy are justified. HAPS can collect substantial data, including visual imagery and geolocation information, potentially leading to continuous surveillance without consent. Fourth right is the right of the rights of the child. HAPS deployment may lead minors to take riskier routes, lacking safety measures, increasing the likelihood of accidents or harm. The potential limitation of our fundamental rights have also been analyzed, and clear requirements have been set out. First, any limitation must be provided by law and formulated in a clear and predictable manner. Second, it must generally meet objectives of general interest, and we will come back on that aspect. And third, it must take into account necessity and proportionality. Regarding the necessity and proportionality principles, it is crucial to the functioning of the EU. It has been underscored that the use of HAPS for specific policy and operational objectives must undergo a scrutiny based on necessity and proportionality. Failure to adequately assess these factors may result in the prohibition of HAPS deployment, as demonstrated by other case law. In any case, the rights may be limited, but the essence of a right still must not be interfered with. If we deep dive slightly into the general interest aspect, there are three factors to be considered when assessing the general interest argument. First, the improved border security. HAPS would enhance, for example, Frontex situational awareness on EU external border, enabling real-time monitoring, improved surveillance, and more effective data collection. This will lead to early detection of illegal activities, such as drug trafficking, human smuggling, and organized crime, while also helping to prevent dangerous situations and summary returns. The objective of securing borders and combating cross-border crime is considered a legitimate public interest. Second, the enhanced public safety. HAPS Earth observation capabilities improve monitoring and early detection for disaster, benefiting search and rescue mission, maritime security, and forest fire management are all positive aspects. Its communication capabilities facilitated better response coordination during critical missions. Also, regarding internal security, HAPS can support continuous surveillance of point of interest, as we have seen during criminal investigation, such as potential drug production facilities, thereby contributing to the EU internal security. The technology telecommunication network and communication interception capabilities could assist European law enforcement in various operational activities, always under judicial oversight and appropriateness. The study also analyzed some absolute rights. It must be noted that there is no clear-cut definition of what an absolute right is, but based on the Charter explanation, ECHR and case law of European courts, some rights could be considered as absolute. We can provide an example such as the prohibition of torture. It is a limited list of fundamental rights that need to be absolutely protected. Under no circumstances can the deployment of HAPS limit or restrict those rights. And of course, necessary safeguards need to be implemented to prevent a negative impact. After an analysis, it was demonstrated that with the right safeguards in place, the implementation of HAPS would not impact absolute rights. If we now move to the conclusion of the third and final report of this study, we can say that concerning positive impact on the rights holder and concerning Earth observation, the improved surveillance capacity for the EU Innovation Hub members may play a crucial role in disaster management and humanitarian aid efforts. HAPS could enable them to capture up-to-date high-resolution imagery and sounds and map large areas more easily. As a result, the authorities involved could be able to take the necessary action and prevent or intervene much more swiftly. Additionally, it could play a central role in the oversight of regions where potential infringements of fundamental rights are taking place. This could contribute to capturing the required evidence to take the necessary actions aimed at ensuring justice and protecting fundamental rights. Concerning navigation, HAPS technology has the ability to enable and enhance global navigation satellite systems, GNSS, connectivity in remote areas, such as mountains or areas with dense foliage. As such, it would allow systems like GPS and Galileo to provide more accurate positioning, navigation, and timing information that is vital for various activities, including emergency services. And regarding communications, HAPS can be considered as essential communication infrastructure in areas with limited or disrupted connectivity, for example, in remote regions or during natural disasters. By enabling reliable and resilient networks, these high-altitude pseudo-satellites can improve emergency communication or just general communication. If we now look at the safeguards that should be implemented to mitigate the negative impact, it is crucial to establish a clear and fundamental right compliant legal framework explicitly permitting HAPS deployment. This framework must define its scope, purposes, and necessary limitation, ensuring transparency and proportionality. Robust measures such as data anonymization and accountability mechanism should also be included. Conduct relevant assessments and involve rights holders and civil society in its development is a key success factor. Implement also a clear collaboration and procurement agreements with third parties involved in the HAPS operations. Attention when collaborating with third parties around the HAPS topic. A thorough fundamental right due diligence exercise is absolutely necessary. Assess the risk, define third parties' responsibilities, and encourage safe legal entry, while discouraging dangerous routes could be very beneficial. This agreement with third party should be subject to adequacy decisions by the European Commission and include fundamental rights provision in procurement documents. The third safeguard is to enhance transparency and accountability through clear policies. Internally, it should be noted that guidelines must be created, also mechanism and training program for staff to ensure HAPS uses aligns with fundamental rights principles. Externally, it must be important to communicate transparently with rights holders about HAPS deployment, its limitation, and the deployment areas. And finally, it's important to establish periodic reviews of HAPS impact on fundamental rights involving independent oversight and consultation with rights holders. These reviews ensure the effectiveness of safeguards and adapt them to changing circumstances, such as evolving HAPS capabilities or deployment context. We have now reached the final conclusion of this whole study. As a reminder, the overarching question of the study was to assess if hubs could be a capability enabler for Frontex and the EU Innovation Hub members' operations. This entails three sub-questions that were analyzed in this study. First, how is the market and what is the future outlook for development? Second, how advanced is the technology of hubs? And third, is the use of hubs feasible in relation to the respect of fundamental rights? Regarding the market, we have discovered that there is a growing market and that hubs can play a significant role to bridge the gap between UAS or drones and traditional satellites. It's more robust, more cost-effective than satellites, more robust than UASs, and its payload versatility and coverage makes it a prior technology. A globally growing market and with some potential go-to-market as early as end 2023 or 2024, but it still faces regulatory lags. On the technological assessment side, it has a clear technological potential for the EU Innovation Hub members. There are some challenges like the technological complexity, the environmental factors, and as we said, the regulatory gaps or lack of regulations. Three main use cases and five specific use cases have been identified and analyzed, and we can conclude that hubs can bring an added value. And finally, regarding the potential impact of hubs on fundamental rights, it could positively impact certain rights, but also negatively impact others. Therefore, some strict safeguards need to be put in place. In any case, a deeper assessment on a case-by-case basis must be conducted. So can hubs be a capability enabler? This research study on high-altitude pseudo-satellite sets out a clear answer. Based on all the elements analyzed, it can be concluded that hubs has a real potential to be a capability enabler. In particular, Earth observation and communication-related operations, ideally combined with the deployment of other technologies, could elevate the day-to-day operations of the EU institutional actors related to internal security. It should be noted that the legislative framework in the EU should be further established to facilitate the deployment of hubs and regulate activities in the stratosphere, and that the deployment of hubs in all cases warrants a detailed fundamental right assessment. Nevertheless, the approaching commercialization of the first hubs platform expected for 2024 and the real technological advantage which hubs bring should be considered and deserves further research on a case-by-case basis. We have now reached the end of this webinar. We hope you enjoyed it. We can only stress that there is much more information in the reports, but also in the visual insight or the booklet that are published on the Frontex website. So if you wish to know more, or if you're looking for specific information, feel free to visit the Frontex website. Thank you.